let's solve this problem. The set 1 by n sine 1 by n has, so they are asking about the limit point. So here if you do limit n tends to infinity 1 by n sine of 1 by n, so you would be having a little confusion on what will happen to sine 1 by n, because if you apply n tends to infinity, this becomes sine 0, so it becomes 0, and hence if you do put infinity, it becomes 0. But this is not the right way. Okay, let's solve this problem in a two way. Let's see, look at this problem in two ways. Okay, so the first way would be, I'm going to substitute and see 1 sine 1, 1 by 2 sine 1 by 2, and so on. Okay, so let me plot this, and you should know that sine 1 sine 1 by 2, so everything will lies between in this region. Okay, so this is my 1 and this is sine 1, so this is my graph of sine from 0 to 1. What I'm doing, so if I multiply with 1, because I'm having 1 here, right? So that is, I'm having 1 here, 1 by 2 here, so I have to multiply this sine graph with sine at 1, I have to multiply with 1, at 1 by 2 I have to multiply with 1 by 2, right? So how my graph will look like is, because this point or lies between 0 to 1, you know the behavior of the points that lies between 0 to 1, that is, if I multiply 0.5 or 0.8 into 0.1, what happens is it becomes so small. So my graph would be like this. See, this is my sine 1 graph, or this is my sine, here it is my sine 1. Okay, so what happens is, I'm going to approach this 0 with multiple of 1, so with a multiple of 1 by n, right? So what happens is, like, the graph will be looks similar, but it approaches a quicker way. That is, I can write the second term for you, okay, in order to not to confuse. So this is my thing, and sine 1 by 2 will be like this. Okay, so I'm marking this as the sine 1 by 2 because this is my 1 by 2, this is my 1. Okay, so sine 1 by 2 into I'm doing half I am multiplying. So what happens is, sine 1 by 2 is already lesser than 1, right? And half is again less than 1. What happens is, it reaches to this point. Can you understand what I'm telling? Like here it will be half into sine 1 by 2, here it will be 1 into sine 1 by 1, here it will be half into sine 1 by 2, and so it goes on and on like this, and it reaches to here like this, somewhat like this. The question is actually about the limit point, that is, this is my first term of the sequence and this is the second term, and goes on. Okay, why I have done like this, because this is actually my sine 1 by n graph, but you should know that the graph is not a continuous, because this is a kind of sequence. Okay, so what happens is like this, this way, because the graph is not continuous. So this is my first term, second term, third term, fourth term, and so on. So like this it will be like. So ultimate, what happens is, your sequence just approaching to 0. So this is a picture view of this sequence, that is, this is a picture view, and you can obviously know that your sequence are ultimately going to 0. So this is one of the way, and the other way is, so just do limit n tends to infinity. This is the quickest way, because you cannot able to picturely you can view this. Okay, so this is bounded. So however the n varies, n becomes infinity, or n becomes more than like k or something, whatever the numbers are there, it is bounded obviously, right? So my 1 by n tends to 0, so 0 into something that lies between minus 1 to 1, because sine 1 by n lies between minus 1 to 1, but in the graph wise it is actually not minus 1 to 1, it is from 0 to 1 only, not actually 1, sine 1 only. So clearly sine 1 by n is bounded function, because sine 1 by n can take these many values only. So sine 1 by n is bounded, and 1 by n tends to 0, so 0 into something, some finite value will obviously gives you 0, and hence the option A is the correct option.